So, all right. Welcome everybody to the Cyberbot Educator Workshop. This is day 1 of 3. These are occurring on March 25th, 27th, and 29th of 2024. This is a link to the slideshow, and I'll go ahead and chat that to you. You are welcome to open it. I recommend also bookmarking the link because it will really help out if you want to refer back to certain items. And I'm looking for my Zoom controls, which I seem to have misplaced. So sorry for the temporary delay in. Oh, wait, I think I saw them. There they are. Okay, chat. Paste. So that should be to everyone. And now I need to try to make sure that my Zoom controls and that are in a better spot than desktop number 4. Sorry about the delay here. Okay, much better. All right, so is everybody able to see the link to the slideshow in their chat? Can I get some thumbs up? Either. All right, looking good, everyone. Beautiful. And then always feel free to just jump in and say, hey, Andy, I can't see it, or whatever. If you want to unmute yourself, that's perfectly fine. Also, doing it in the chat, that will make it to Ari, and then he might end up bringing some things to my attention to answer to the group, and he might also chat you other answers directly. Okay, so for those of you who have a single screen, it's going to be useful to sometimes have this presentation. It's probably filling your screen right now, but it'll be helpful to have this presentation side by side. So if you move your mouse around, and this is only for folks with a single screen, you can click View. And when you do that, you'll get a little drop down and you can hit Exit Full Screen. Once you've done that, then you'll be able to resize it. And I recommend resizing it like this. Like here's the Zoom meeting on one side, and then here's, we'll have our microbit Python editor up on the other side in a little while. So that's an example of something that we'd have side by side. Now you can always click the restore button to fill up the screen if you're not doing anything at that moment. And then there'll be some times when you want to then go back to the half your screen version. And again, if you have more than one screen, don't sweat it. Just arrange things so that they're comfortable to view. This is our education department. I'm Andy Lindsay. Ari Alvarez is our company vice president, and Stephanie Lindsay is our product and documentation manager. Today, Andy and Ari are with you. All right, so let's talk about what we're going to do during this workshop. Today, there's going to be lots of introduction and overviews and general information. We'll also review some of the stuff that you did as homework, answer any questions while we're there. And by the end, we want to have our Cyberbot board connected to our microbit, and we're going to calibrate 2 servo motors. And then between today and Wednesday, we'll have you build your Cyberbot robot. For any of you who have already built it, that's okay. I'll show you a trick to adjust your servos without completely disassembling the robot if you have adjustable servos. All right, on Wednesday, we'll start with Q&A. Then we'll do some navigation and some computer science concepts as applied to a robot. And then we'll also build some circuits called whiskers and test out touch navigation. Then we'll have you build another sensor circuit for Friday, and we'll try that out, look at and troubleshoot it as needed. And then we'll look at some other circuit applications that you can do with the Cyberbot, as well as some cybersecurity lessons, the educational resources, talk about classroom implementation as well. So generally, as far as the goals and outcomes, we're hoping that you enjoy this workshop. It should be a lot of fun. And we'll also just we'll put some emphasis on the things that I've seen the most questions come in from teachers to try to make sure that you're ready when the students come up to you and say, "Hey, I'm confused. I don't understand what this little dot next to that line of code is, or why can't I get the script to load in my microbit?" Those various and centering servos, which is what we'll be doing today. So those are all things that we'll put a little bit of emphasis on to make sure that if you're using the Cyberbot in your classroom, it'll go smoothly. Let's see here. And yeah, so in general, gaining confidence to use it in the classroom and understanding how it all works. And we'll try to answer as many of your questions as you can, building and programming the Cyberbot robot, of course. All right, so again, open discussion is appreciated, so we want to hear from you. Please do feel free to unmute yourself if you have a question or are stuck on something, because quite possibly one or more of the other attendees might be stuck on the same thing. Now, some things, especially if it looks like gee, my computer doesn't seem to be talking to the microbit. Sometimes we have to wait till the end of the class if the first few tries don't pan out, because it can end up easily eating up some time, and we do that offline as like a tech support kind of thing. This is Chip and Ken Gracie. They're brothers that started up Parallax. Chip is our chief inventor, and Ken is the company president. Chip designed well, he's created a lot of things, and I'll tell you more about that in a minute. Here is Parallax. I'm just to the left of this window right here as we speak. And we have about 20 employees. I've been in business since 1988 and developing and supplying educational products since 1997. My name's Andy Lindsay. My educational emphasis was in electronics engineering, so I am not a teacher, but somehow I ended up developing lots of material for teachers over the years, and I look forward to any tips you might have on making this more usable for you as we go. We learn a lot from you during these workshops. Parallax is about modern electronics, and by that, I basically mean electronics where you have some kind of programmable device that's actually talking to the electrical and electronic components. So behind each of these buttons on this alarm clock is, well, when you press one, it changes a circuit inside the alarm clock, and a programmed microcontroller, a chip that's like a computer, but it doesn't have an operating system. It just runs a single program, is the kind of thing that monitors that that electrical change, updates the display, figures out what time it is and makes the alarm go off. Likewise with the microwave oven, when you press a button on there and it makes a beep, it's because an electrical connection changed and the microcontroller detected that, and its program told it that the next thing it should do is beep and update the display and that kind of stuff. Likewise with cell phones, microcontrollers are also found in lots of student projects and inventions. Parallax got started with the basic stamp. Our chief inventor, Chip Gracie, is the one who made this back in the mid-90s, and it basically changed electronics education. It was the first of its kind thing to make a programmable device easily accessible to basically everybody. At the time, it had the beginner's language of choice, which was BASIC, and you could write a program and easily connect up circuits, and we made this educational robot, and it became really, really popular. Now, in the meantime, a number of other microcontrollers have come on the market that were designed for for a younger crowd, so to speak. And so we have taken those and the same kind of lessons and adapted them to the Arduino and the Parallax Propeller microcontroller that we designed. And then the most recently, we've set it up for the BBC microbit. And that's the Cyberbot robot that you have that we'll be working with today. So here we have the microbits. There's a version 2. There aren't many version 1s around, but they do work in this system just fine. The advantage of the version 2 is it has about 3 times as much code space, which is nice. You don't run out of room to write your script quite as quickly. And it also has a built-in speaker and a built-in microphone. Let's see, and a built-in touch sensor. So there's some extra things along with all the cell phone like goodies, like a built-in radio, push buttons, and a touch interface for control, a rudimentary display, and then built into it, I believe in this little chip right here, we have I'm sorry. This little chip right here is a compass and an accelerometer. And then this is the processor. And of course, you can program it with USB. So it's kind of neat. It's like a little microcosm of a cell phone, which students do tend to find to be engaging when they can program it to make it do things like detect tilt, just like your cell phone does when it adjusts its screen when you rotate the phone, for example. All right, so here is the Cyberbot robot with a microbit attached. And what we're going to do today is put together this board. We're going to connect the microbit to the Cyberbot board, which is this larger board. And that's going to be the control center for the robot, the programmable control center. And then the motors behind these wheels, we're going to break those out and calibrate them before the day is over. So to do that, actually, so before we get started on that, I just want to mention a few resources up front, and then we'll also talk about them on day 3. So the first one here is the student resources. This is the Cyberbot robot table of contents for the online textbook. And so these prerequisites are about using the microbit and also how to program it. So there's a lot of computer science goodies in here. And writing microbit programs is where you were earlier on. And you, for example, in the homework, went to the LED matrix display and had it display a simple hello message, and then also created some variables, for example. And I'm getting ahead of myself. That comes a little bit later in the presentation, but that's an example of one of the chapters in the prereqs here. And after getting a strong foundation in writing scripts or programming, then we put together the Cyberbot and learned to make it navigate, learn to make sounds, start building some circuits and testing them, making sure that the microbit and Cyberbot board can monitor and control the circuits. Then we start making, so navigation lessons are here, and there's a lot of scripting goodies that students learn there. And then after building sensor circuits on the Cyberbot, then students can also are guided through writing scripts to detect when the Cyberbot is bumped into something, whether the light is brighter on the left or right, whether there's a non-contact version of these contact sensors that uses infrared flashlights. Then we get into radio control, which is pretty cool, and we can do like keyboard navigation and tilt control. And then there's some cybersecurity lessons where students learn to secure their radio communication so that other students can't interfere with that. There's also teacher resources. And I should paste you that link. And so what we have here is there's some stuff up front, strategy guide, these slides, standards matrix, scope and sequence. And so these you can take a look at your leisure. There's also an area where you can log into to get the teaching materials, the assessment materials. And we'll have you between Wednesday and Friday email education@parallax.com and request a learn.parallax.com account so that you can get to the assessment materials. And so we'll be again talking about that on Friday, and we'll have you get ready to see it by signing up on Wednesday. Okay, the Cyberbot can also be purchased from parallax.com. So I put a link to the various Cyberbot kits in the slides. And let's see, I did Cyber Teachers. Okay, let's see. And so the kit that you started with is the Cyberbot kit with microbit. There's also one, if you already have a microbit, there's a version that does not include the microbit. If you already have a classroom full of microbits, that's an option. If you have a different version of Parallax Robot and you want to upgrade it to the Cyberbot, we have an upgrade kit. And then there's also classroom packs that have additional goodies like rechargeable batteries, and battery chargers, along with additional sensors for line following, TV remote control, and then a swiveling ultrasonic detector, and then cool things like the gripper as well. There's also we have a microbit catalog that you can get to in case you ever need to get microbit modules. So this is the microbit category, and it takes a little bit of searching, but here is, for example, the V2 Club bundle right here. And that's a 10-pack of microbits. And then there's also individual microbits. Let's see if I can find that. Where did it go? Here it is. So here's the $18 Microbit Go bundle. Great value for a microcontroller. Okay. Now, the last thing I wanted to point out to you in terms of resources is the upcoming workshops page. I'm pretty sure you've seen this because not sure how else you would get to sign up for the workshop, but just so you know, here it is. And we do still have upcoming workshops, both online and in person. So this is the one that's occurring right now. The next one that's up is going to be cybersecurity about a month from now. And then there will be some in-person events coming up in June. Okay, real quick review and question and answer of the homework. So how did it go? How did the homework go for everybody? I'm getting some thumbs up. Good. So you were able to write some simple scripts and get it to say hello and get it to do something a number of times and all those things. All right. Well, very good. Excellent. Excellent. So in that case, I think I'll just mention for the sake of anybody who's coming to watch this later, because there are some folks who do this in a self-paced learning kind of style. So here we have a link to the Cyberbot robot that you'd be using, or that you received in the mail. And then here is the link to the Get Started with Python and the Microbit chapter. And then these are the individual links to the homeworks that basically these were the individual pages that we had you go to. Instead of doing the entire chapter, the instructions said, well, just go to this page and follow these instructions. And sorry, this is about getting started with the microbit. So each of these pages in the get started with the microbit part has a how-to video, and then the step-by-step instructions that were followed in that how-to video. And so with that, we're hoping that there's a higher level of success in getting started with the microbit. And we also go through, how to save your work and how to collapse and bring back the side panels. And again, all of these have instructional videos and then step-by-step instructions. And then there's also a serial monitor, which comes into play more in the cybersecurity part of the curriculum. And then some materials, and you don't need these all today. Today we'll want you to have the AA batteries. I sent out an all points bulletin about that. Go ahead and paste you this link, because you'll want to have these for next time, because we'll be breaking out the circuits, and those have small little parts. So basically some sorting trays, Ziploc sandwich bag. That's for storing the batteries. It's good to keep them away from the small electrical parts. And then a magnifying glass, or use your cell phone's magnifier app. It's that's a perfect replacement for a magnifying glass. And then we talked about the homework, which was in the writing scripts area. So we did the scrolling text, remembering, doing some arithmetic, making some decisions, counting and repeating. And so here's the beginning of that page. And then what I have is a script that I think is not too long to paste into you, that you can try with your microbit. And I'll demonstrate it first, because this is slightly adjusted from the way it was in the tutorial. So what we'll start with is Chrome. And then we'll go to python.microbit.org/v/3. And I'll paste that into you in a second. And then what I did was I just made the simulator go away so that there's some more room. And then we'll paste this script over to try it out. And again, what this does is, instead of using display.show to see the messages on your microbit, this uses print, which will allow you to see the messages in the serial terminal. And so I'm going to go ahead and connect to the microbit. And you can use the don't show this again after you've gotten used to it. And just to emphasize, you have to, in the next pop-up that comes up, you have to choose the BBC microbit and then hit connect. So there's the pop-up. I'm choosing the BBC microbit and hitting connect. And then it says the microbit is ready to flash. It's connected. So we'll go ahead and by flash, that means to load the program into the microbit module's flash memory. It's like a USB drive style memory. In what circumstances would there be multiple microbits to choose from? Very good question. The most common situation for that is when you're doing the cybersecurity lessons as an individual, say, maybe doing home study. In the classroom, each computer is going to have typically a microbit connected to it, and two of the microbits might be communicating, and a third might be monitoring that communication to demonstrate how, for example, a sniffing attack works. But if you're doing the at-home version, you might have more than one microbit connected to the computer, and you've got, two that are talking to each other, and then maybe a third that's monitoring the communication. So that's an example where you'd have to choose multiple microbits. Another thing about that is it's simply a security measure that has been put that is designed into browsers for making USB devices safe, that it absolutely requires action on the user in order to connect to that peripheral device. So that they don't want scripts to be able to just jump into browsers, find peripheral devices and take them over. So that's why they have this this very specific, okay, I'm choosing the microbit and I'm hitting connect. Okay, what if it pairs but does not display on the microbit? Well, so if you hit connect, now it's disconnect. So do try the three dots and tell me if it's showing disconnect. Don't disconnect, just tell me if it's showing disconnect. And then when you say won't send the script to the microbit, you have to hit send to microbit again to have that script go in. Now, nothing happens on the display with this script. Let's see, can we rename the microbit so we as teachers know which one is which? Not that I know of. What I do when I have more than one microbit connected to a single computer is I look at the last four digits because it'll show serial numbers for each microbit. Let's see here. Yes, it does disconnect. Okay, great. Shows disconnect as an option. All right, well, if it shows disconnect as an option, the next thing to try is just hit send to microbit again and see if it will successfully flash this time. And so once it flashes, what you'll do is you'll open the show serial, and I'm just going to run it again, and then hit enter, and it says basically each time I press enter, it runs another part of the lesson. Okay, let's see. It shows it flashed, but no display. Well, that's correct. Oh, well, now it depends on what script you're running. If you're running the default script where it says display.show, but you don't see any display, I got a couple of questions about that earlier today. There might be like a Chrome update that's making it behave a little weird the first time around. So I will show you how to fix that. So let's see, what I'm going to do is, I guess, maybe disconnect here. And then open another instance of the editor. Let's see, it shows flash, but okay. My script is display image.heart. Okay. All right, well, what I would do is I would go back to the default script to begin with. So I'll paste the default script in for you because we want to make sure that that's correct. So here you go. All right, and then once you've got the default script in there, hit send to microbit, go through the connection rigmarole, and then see if it displays the heart and the hello message. And then one last thing to do would be just to change the script a little bit and flash it again to make sure that it responds by, that this little display, instead of displaying hello, it displays hi with an exclamation point after you make the change and hit flash again. Let's see, am I using oh yeah. Let's see here. So yeah, you want to use either a Chrome browser or a Microsoft Edge browser, not Firefox. And it's a Windows PC. Also, I don't think that Mac Safari supports this either. So it's mainly Google Chrome and Microsoft Edge. see, Edge and tried Chrome, same issue, Windows 11. Okay, well, what we'll do is we'll take a look at that during the break. Oh, no, I'm sorry. Okay, one more thing to try, and this worked with at least one person this morning. So you have this script in here ready to go, and you hit send to microbit, but it didn't respond. All right, so if that's the case, hit save instead. I'll give it a name like test. Confirm and save. All right, so now test.hex is in your downloads. So again, you hit the save button and you'll get test.hex in your downloads. And you can actually go to your file browser. So that's in Windows, that's going to be your File Explorer. And just a sec, it appeared on another window. And so what you want to do is you'll want to go to downloads, and hopefully there's going to be a test.hex file sitting in your downloads, and it's probably best to sort by date so that this trickles to the top. So if you can right click your browser, click view, and then oh, I'm sorry, sort by, and then you want to do date descending, and then that way, let's see here, unable to claim interface, another process is connected to this device. Okay, yeah, so it's saying close other tabs. So that may mean that you have another tab open. Like here, what I did is I was very careful in this tab to disconnect. So it's offering me to connect. Then I came over here and this one is connected. So it's offering me to disconnect. So you only want to have one tab open at a time. So try to find other tabs and close it. Saved my hex file. Okay, very good. So if you've saved your hex file, you can load it into the microbit by dragging and dropping it. See down here, your microbit will look like a flash drive. And this is kind of the backup way to load a script into your microbit, is to drag and drop that hex file you saved into the microbit, just like you're copying it onto a flash drive. And it even looks like it's, it for all intents and purposes, as far as the computer is concerned, I should say, the microbit is a flash drive. Okay, so I got a thumbs up for that from Nielka. But Phyllis, let's see here. So Stephen is the one who had the unable to claim interface, and Phyllis, okay, not copying, Phyllis. Okay, so there's something going on with your computer. Yeah, well, let's talk more during the break. The only other thing I can think of is that you might try unplugging the microbit and plugging it into a different USB port, if you have another USB port. You could also try just unplugging both ends of the microbit and plugging them back in firmly. And then the rest we'd have to do during the break or after the session. Okay, very good. Sorry that happened. All right, so back to now about that unable to claim interface. So here I was connected, and so I'm going to disconnect, and then I'll go over to this tab and connect. And now it's safe to, if they were both connected, you might see an unable to claim interface message. All right, and then again, each part is from your homework. Like here we have print hello. So instead of going on the display, it's appearing here in the terminal. And then basically when you press enter, then it'll continue. I'm going to click the terminal, press enter, and it continues to the next part, which is showing A is 2, B is 5, etc. And then it prints all those things, and we can see those in the terminal. So this is a good exercise I would like you to try. And so I'll go ahead and paste it in now that you have seen it. Paste. Oh no. Paste. Send. All right, so make sure that's kind of long, so make sure to copy the whole thing. And then paste it into your python.microbit.org editor. Now you may find that you need to, it might not take on the first try. I've noticed that this serial monitor sometimes doesn't show it on the first try. You can just click, even if it's blank, you can click and hit enter, and you might see the second part of the script. And then if you run this, if you send the script to the microbit again, it should at that point start from the beginning. And then you can go through and say, okay, here we're so we already talked about remembering. So we stored some values and variables. And then there's a calculate, which takes A and B and adds them together. So we're expecting the answer to be 7. There it is. Then there's going to be decide. And let's see, A is 2 and B is 5. So in the decide part, it should display B is greater. Yep. And then in the repeat, it looks to me like it's going to count to 10. Or maybe to 9. All right, and so remember that it starts inclusive and ends before it gets to the ending argument. That's one that will confound students. It's a programmer's thing where essentially it's much better for crawling through data later on, but it can be a little confounding to have it include the starting value, but not the ending value. So that students may need a little bit of reminding about that. And then this is an endless loop. And there's something I want to point out, which is that here we have a variable n, but that variable n is only used inside this loop. It's not declared anywhere upstairs. We declared A, B, F, and T, but not N. And so down below here, we actually had to say, okay, N, we'll declare it to start up at 10, so it continues from where it left off here. And so this is an infinite form, or an endless loop, whereas this is a loop with bounds. So next time I press enter, it should just continue counting. And so that's a quick review of the homework. I'm open to any questions. Phyllis, you got it working. Fantastic. During the break or afterwards, let me know how you did it. Or just text. And so let's get some thumbs up. Were you all able to see those results? Very good. Okay. Now I'm not seeing I'm seeing a few folks still trying stuff out, so I'll wait. And thank you for the thumbs up in the chats too. Okay, we got some more coming through. Yeah, so everybody's still working on that. Good job, Trish, Tony, Anna, Jess. Chiani? Sorry if I didn't say that right. E. Murphy, Lexi, Phyllis. All right. And then a few of you put your thumbs up earlier. Okay, so are we ready to move on? Feel free to give me a thumbs down or, okay, I'm getting lots of nods now. Very good. Perfect. Let's go. Agreed, Anna. Okay. By the way, so as a slide reference, if you want to use this, it's just hidden down in the notes. So you can actually, when you're on this slide about the homework review, you can just grab the little the little presenter note separator and drag it upward to get to that script. It's a little extra that's not in the documentation. Okay, just wanted to bring to your attention that underneath the microbit, there is a reset button. As a warm-up, some of the microbit.org projects, these can be a great icebreaker for the microbit and just to get the students enthusiastic and having fun. And it is kind of cool in that it does also give a hands-on introduction to those same concepts that we talked about of memory, of communication, of decision repetition, et cetera. And so we start with just simple communication. And then a beating heart would be adding in looping or repetitions. An emotion badge where you can press A or B and get a smile or a frown adds in conditionals. So now we have communication, conditionals, let's see, communication, conditionals, and repetitions. And then by the time we get down to your step counter, that's really got all the elements. So let's try that one. It's kind of cool too. So I'm going to copy this in. Now I want to emphasize that it starts you with make code. We're sticking with Python, and so there's a Python tab here. So you can get to this code through the Python tab. Although you can open a new Python editor, I don't recommend it because, again, there's that possible problem of having two Python editors fighting for the USB connection. That's somebody mentioned they got an unable to claim interface message, and that's what that's about, is you have more than one tab that's trying to talk to the microbit. So you're best off just copying this and then pasting it into the editor and running it. And I'll just demo this real quick. Okay, so now we're going to be back to the display. And all you have to do is give the display a shake, and that'll emulate a step. Okay, with that said, I'd really like you guys to try this one. So here's the link. Remember to switch over to Python, shade and copy the example script, and then paste it into your microbit Python editor. Paste. So go ahead and try that out from Make It Code It projects, or I'm sorry, from Make It Code It microbit projects. How do we switch to Python? Okay, let's repeat that. Where was I? All right, so it'll present showing you make code in the step 2 code it section. And all you have to do is hit the Python tab to switch over to Python and grab that text and then paste it into your editor. See, oh, I modified the earlier code to scroll n equals on the microbit rather than in the input box. I can see our students spending a lot of time just watching the numbers. Yeah, some moderation will be in order there. kind of have them move on to the next topic after a minute or two. Okay, show me a thumb up when you've got your step counter shaken and stirred. Wow, that's fast. So some of you are moving right along. Okay. Jess, Tony, Murphy, Anna, excellent job. Mary, Melissa. And I think I saw Catlin and Michael And Lisa, give me a thumb, or no, maybe not Lisa. I don't know, Lisa. Did you give me a thumbs up already? No, okay. Okay, let's see here. How do you paste into the editor? Okay, so again, going back to the step counter example, you can basically shade and copy, right click and copy, and then go over to your editor and you can shade everything and then paste. Or another thing you can do is Control A. That might be Command A in the Mac, or but Control A, I think, at Chromebook and Windows, and then Control V is the fastest way to select all and then paste. You can also right click and select. No, it doesn't give you that option here. Select all, Control A, and then paste is Control V. All right. So the thumbs ups are slowing down, so I think we got most of you through it. Give me a shout out if you need some more time. Otherwise, go ahead and hit the next thing. All right. So I put this in the wrong place. I meant to have this in resources. Let's see here. So we'll put it right there. There we go. So this is a link to a microbit only workshop. It's a YouTube recording. And so this is just an example of some additional information about using the microbit on its own before going to the Cyberbot. Let's see, can you do more practice using variables? Oh, by all means. Now, I don't want to do it during this workshop, but there is an entire chapter of, or well, there's an activity that uses variables, and I think there's more than what we had you, that little bit that we had you do. And then also, if we go to the Cyberbot page, so learn.parallax.com, Cyberbot, variables also get used more and more. So for example, the first place where variables was used was in remember and use values. And we had you do this little thing for homework, and then I just did kind of a little similar thing to that. But there are more scripts here that make use of variables. And then in computer microbit talk, variables are used again. So for example, here is a script where we're storing something that the student types in, a number, and then we're converting that number's text into an actual value, and then using that value to count down. So variables end up getting used more and more as you go through the tutorials. And then with a dictionary primer, a variable can now be an assigned name to a dictionary. And so variables will get used quite a bit in these scripting fundamentals tutorials up here. All righty. So next up, oh yeah, so here's this was a link to a microbit only workshop. It's got lots more examples like what I showed you with the step counter and the Make It Code It site, which again, I think is a fantastic site for kind of a warm up, getting the students enthusiastic before even starting with the Cyberbot robot. And it'll also strengthen their understanding of how scripting works. Can have them do the fun stuff first and then go through the tutorial that you guys did as homework. And then, so now we are at build and test your Cyberbot robot. Now, what I did was I set up links to the existing tutorials. Okay, let's see. Are we getting an educational account for Parallax resources? Yeah, so we'll be signing that on Wednesday. Because before then we'll just be using all the publicly available resources, and then the assessment material is the only thing we keep locked away for teacher only access. All right, so so I'm going to show you where the student tutorials are. So basically, this is the start of Build Your Cyberbot Robot, and we talk about the Cyberbot board, and then go into gathering those parts and connecting it, and then picking out your servos and connecting them and adjusting them. And so this is the student workbook stuff. I just wanted to try out instead some support slides for this. And then some of these images will most likely be going back to our website so that we can improve that later. And then, yeah, so here is eventually you'll be blinking a light. And so these are all links to activities within chapters that that the students would follow as they get their Cyberbot board connected and up and running. And so what this is kind of a visual summary of that. And I want to try it out and see how this goes. So what I'm doing now is I'm saying, okay, hey, when we have our battery connected, when we've got the USB connected, we can put a script in there and set power to 1. And we want success will be if the P21 light blinks. Now, it won't blink automatically. We'll have to write a script to make it blink, but that'll be the test. Let's see, will we get a recording for today? Yes, absolutely. I usually send that within 3 hours of the end of the workshop. I send a temporary link, and then a day or two later, we'll send out the permanent YouTube link. The temporary link is on Zoom's cloud, and you can watch the video and see all the same things that you'll see on YouTube. It's just I want to make it so that everybody can get to it as quickly as possible in case they need to catch up for the Wednesday workshop. So again, we'll start with a recording that's on the Zoom cloud, and then a little later I'll send out the YouTube. See, would you say that this is geared more to K-8 versus high school? I would say this goes 8th grade to high school, through high school. Yes, sure thing. All right, so here we have the goal. We want to have our microbit connected to the Cyberbot board, batteries plugged in, USB cable, power on, and load a script, and then the light will blink. So to start that, we need these parts. So go ahead and break open your Cyberbot robot kit and find these parts. There's a longer USB cable that's kind of nice to have with the Cyberbot. There's a little tiny one that comes with the microbit. So I'd recommend seeing if you can fish out the longer cable. You'll need your microbit. Oh, you've probably already got that connected, sorry. So really all you need to do is go digging for the Cyberbot board. It's going to be in a silver bag. And give me a thumbs up when you've got that. Oh, fast. All right. Okay, so next up, you're going to take that microbit and slide it into this edge connector. Yes, I love the long cable too, and thank you for the thumbs up, everyone. I'm glad that went quickly. So go ahead and insert your microbit firmly into the edge connector. If you look at this picture on the right, you'll see that the little circles above and make sure that the LEDs are facing up and this Cyberbot board is facing up before you insert it. And when you insert it, you'll want to use a little bit of muscle, and these circles will be just a little bit more than half covered by the edge connector. Let's see, do we need to unplug the microbit from the computer first? Yes, shame on me. Yeah, I think it's much better to not have it powered up when you make the electrical connections. I haven't ever heard a report of damage, but it's just a good general habit to always disconnect power when you're making any kind of circuit connections. And then give me thumbs up when you're ready for the next step. Oh boy, you guys, some of you are really, really trucking. Okay, I'm waiting for a few more thumbs to come through. All right, yeah, this is looking good. Excellent work, everyone. Okay, so now that you've got your microbit plugged in, you want to grab a few more parts. So you'll want to grab your brand new, hopefully, AA alkaline batteries. And then down in the bottom of your kit, probably tucked inside the chassis in a bag, is going to be this battery holder. And you don't necessarily need to unplug and wind up your USB cable. You can just, you know, have it still connected to your computer. And it's fine to reconnect it to the microbit too. So anyway, grab your AA batteries and your AA battery holder, and that one will take some digging. See if I can find all these parts myself. All right, so here is my kit. This is the Cyberbot board. This is the nice long USB cable. And then the battery holder is tucked away in this aluminum chassis. So you'll need to kind of dive in there to pluck the battery holder out. There we go. And you know what? While you're in there, the two servo motors, you're going to need those too. So these little servo motors with the four-pointed star, little black boxes with four-pointed stars on them, go ahead and grab those since they're inside the chassis as well. And don't worry if you can't find them right away or didn't catch that, because and then while we're there, let's get the screwdriver, though I'm getting ahead of myself. I think those are all the parts we're going to need. Okay, so you want to make sure that the power switch is set to position 0. Load the batteries. Plug the battery pack into the Cyberbot board and plug the USB cable into the Cyberbot board. And the order doesn't matter. And let's see here. After that, set this little PWR, that's short for power switch, to 1. Okay, so should there be no problem with rechargeable batteries? As long as they're high capacity rechargeable batteries, like I think the ones that we have are 2600 milliamp hour rechargeable batteries. The nickel metal hydride tend to have higher capacities than the lithium ion, I think it is. Yeah, nickel metal hydride high capacity are the ones we recommend. That's what we have with the class packs. Let's see, my kit doesn't seem to have the USB cable. Can I use the short one from the microbit? Absolutely. Yeah, no problem there. Okay, and for any of you who might have missed it, again, we've got our battery pack batteries, board, cable, set the power switch to 0, load the batteries in the battery pack, plug the battery pack and the USB cable into the microbit, set the power switch to 1, and you want to make sure the green light above the 1 comes on. All right. So how are we doing? Okay, okay, I got a whole lot of thumbs up. Very good. Okay, perfect. So we're all basically at this stage. Is that right? Okay, excellent. Okay, so next up, we're going to go and grab a pre-written hex file to test that blinking light. So I'll go ahead and give you this link. Okay, so this is from add modules to your microbit, the third chapter. And basically, watch very carefully for a moment. Just want to point out that this is a pre-written script that has some extra stuff added to it. And let's see, no green light above the 1. It's working now. Okay, so for those of you who don't see a green light above the 1 when you put the switch in position 1, try pressing a little extra on the battery pack where it goes into the barrel jack on the Cyberbot board. So that's going to be right here. Press firmly, you might hear a click, and it goes just a little extra distance in. And then when you turn that switch to position 1, we want to see a single green light above the 1. Hopefully everybody can get that working. All right. Oh, very good. So the 2 folks who were reporting issues, looks like they're all set. Okay, so I still owe you a link to this page. But I wanted you to watch real carefully, and this is supported by a video on our page. But let's see. Okay, so here we are at the page I'm going to send you in a minute. See this Cyberbot template with Blink? Okay, this has extra stuff added in under the hood. I'll show you how to see it, but just so you know, it's saving some steps and some confusion. The important thing though is that you need to right-click this and select Save Link As. So that's going to be one of the options in the drop-down menu in Chrome. So you right-click the link, select Save Link As, and then you'll want to just save it in your downloads. And it'll be Cyberbot template with blink.hex. So step 1 is going to be to save it. Then step 2 is going to be to go to your Microbit Python editor and hit the open button. And then we'll have you open that script that you just downloaded. Again, its name is Cyberbot template with Blink. And when you open it, it's okay to replace whatever you were working on. And then here is the template. Now, this might not look like anything special, but there's a big difference if you click the project link. Okay, see how there's main.py and then there's cyberbot.py? So cyberbot.py is hidden away here. And this is the part that does all the hard work to make the Cyberbot talk to the servos and monitor sensors on the breadboard and various other stuff. So the Cyberbot.py is what you're going to need to blink that light. And then this is the main script that blinks the light. And just in contrast, here is the default script. And when we hit project, note that there's only main.py. So like if I were to paste this script, copy and paste it over here, it wouldn't run because cyberbot.py is missing. But since cyberbot.py is present here in project, we know that it should work. All right, so with all that said, let's go ahead and right-click Cyberbot template with Blink. Oh, I'm sorry. I need to send you the link to this page so you can do that. Again, you're going to right-click, select Save Link As, get it into your downloads, then go to your Microbit Python editor, hit Open, and grab that Cyberbot template with Blink. And here you go with that page. Paste. All right, so go to town, everybody. And you can even load it, and you'll want to see the light blinking, the P20. I believe it's the P20 light that blinks. Let's see. No, the P21 light. Sorry about that. Okay, got one thumb up. 2, 3, 4, 5. Okay. 6, 7, 8, 9, 10, 11. Fantastic. Still seeing a few folks looking at their screens and the thumbs up are still on their way in, so looks like that's going pretty well. So what I will do is try to catch up to you guys here. Sorry about the crinkling noise over the microphone there. And I'm almost caught up. Last thing I did before I left my home office was grab 5 batteries and shove them in my pocket, which you should not do if you have keys in your pocket, because your keys could get very hot. I've actually seen somebody do a little dance when they had a 9-volt battery in their pocket because their keys were burning their leg. Okay, so then I'll run the script. And there's my blinking light. Okay, so I think I'm caught up to you guys. Okay, and how's everybody doing? All right, so we have a working Cyberbot board, and I'd like to point out that just in terms of good engineering practices, we're using kind of a very methodical step-by-step testing each little bit of the system before moving on. And so now that the microbit's talking with the Cyberbot board, what we'll do is we'll take a 5-minute break, and then when we come back, we'll connect the servos and calibrate them and make sure they're working. So so it's 10 past the hour now, so we'll see you all at 15 past the hour. Okay, welcome back, everyone. So we are at, most of us have now our blinking light after downloading the script. And just as a footnote to that, essentially, there's the add modules to your microbit page. And there are some common mistakes that are made with this template file. One is you might, instead of doing save link as, if you open it in a new tab, you'll end up seeing why they call it a hex file, because these are all hexadecimal numbers ranging from you'll see that there's F and A here. So those are that's 15 and I think 10 respectively in the hexadecimal numbering system. And so this is the hexadecimal file. And so that doesn't work. So it's very important to right click and select save link as. And it's going to go into your downloads. So we'll go ahead and wait. I don't know why it's at home. Downloads, save. All right. Then once you've downloaded and saved it, you want to go to your Python editor. and hit open, navigate to your downloads, and find the Cyberbot template with blink.hex that you just downloaded, select it and open it. And then you'll have the project. And the thing about this project is that if you hit the project button, again, it's going to show you that there's main.py and cyberbot.py, whereas any other file is just going to be main.py. Now, if you save that, if you save this Cyberbot template with Blink as something else, so for example, I could rename it test Cyberbot board and confirm, okay, and then save it. Okay, it's telling me I saved it, great. Because it had the Cyberbot file, there we go. If I come back over here and open the one I just saved, so I'll hit the open button. Test Cyberbot board.hex, open. The important thing is that I still have cyberbot.py. So it's still a valid, so anytime you save as with a project that started with the Cyberbot module added, you keep it. So it's as long as you start with a project that has the Cyberbot module in it, that's great. When you do any kind of save as, it will keep the Cyberbot module. And so that's important because you need that Cyberbot module to work with the Cyberbot board. See, what is the purpose of this module? The purpose of this module is to basically the microbit sends messages to a microcontroller that's underneath this this board. So right here is a propeller microcontroller designed and made by Parallax that that receives messages from the microbit, and then it's actually taking care of this light blinking right here. And will take care of many of the other tasks. And so what this cyberbot.py module does is it takes care of all that communication back and forth between the microbit and the Cyberbot board. Okay, so it's the software that allows them to talk. Absolutely, well summarized. All right, so next up, we want to connect our servos. And so these are slides, I kind of showed you all this as we were going. All right, so we want to set the 3-position switch to 0 now so that we can connect our servos. So everybody move your 3-position switch to 0. That's going to be all the way to the right. That's your power switch. And next, what we're going to do is we're going to connect servos to our boards. So you'll want to grab the devices that look like this. See, do we need power off again? Yes, absolutely. Turn power off. You don't really need to disconnect the microbit from the laptop if you have the PWR switch set to 0. It's an okay extra step, but I don't think there's really a chance of hurting anything by not doing that, by not unplugging the microbit. Okay, so we'll want to grab the screwdriver and remove, these are called servo horns. I never came to know why that particular term is used to describe these star-shaped levers, but they're called horns. And we want to remove the screws that hold them on and save them. And then we want to pull each horn off the servo. So they'll start looking like this, and then you'll unscrew the screws and set them aside, but don't lose them. And I'll go ahead and do that with you all. So you'll want to find your parallax screwdriver here. And then the two servos. And then basically we'll go ahead and you'll need to hold on to the servo horn as you unscrew with the Phillips end. Remember to save this screw, it's very important. And then pull upward on the servo horn to remove it from the output spline. So again, Phillips screwdriver into the screw that holds the servo horn right there. Unscrew it, make sure to set it somewhere where you won't lose it, and then pull the horn off of the servo, like so. Okay, everybody got that? 1, 2, 3, 4. Okay, so 5. Let's see, mine did not come with a servo horn, interesting. For the one who did not get a servo horn, is the part number on the label, does it end with 40? Okay, thumbs up are still coming through. Excellent. Okay, so for the person who has 40, your servos are factory calibrated, so you won't have to do any of this. But most of us have servos ending with the part number 08, I believe. Actually, let's take a quick, does anybody else have a servo with the part number ending with 40, or does it end with 08? Just look at the little label on your servo. 08, okay. Oh, yeah. All right. So almost everybody has the adjustable servos, and we have one person with factory centered servos. If your servo part number ends in 40, then you can basically just kind of watch along, but you won't have to do anything because it's factory calibrated. All righty. So next up, oopsie, is so now we're about ready to connect our servos. Make sure that power is set to 0. And then look very carefully at this diagram. And again, this is very similar, just as kind of a minor tweak update to what's in the web textbook, which has links in the slides. So we're going to take the servo plugs and we're going to push them down. That each servo plug has 3 holes, and we're going to push it down over these 3 pins. And you want to line it up so that the white wire is on top, closest to the P18, P19 labels, then the red the red wire, and then the black wire. And again, those 3 holes have to go down over the 3 pins that are sticking up below P18 and P19. And your board will be preset to 5 volts. There's a little jumper here that you could pull up and set to VN, but that would give battery voltage to the servo. And with the exception of the one person who has their servo part number ending in 40, all the 08s need to have 5 volts only. So that's okay. So again, make sure that white, red, black from closest to P18, P19 down to the bottom. Okay, so here we go. Got power turned off. Set to 0 here. And so I'll go ahead and take one of these cables, and I want to set it up so that the white wire is toward the top, then red, then black. And then I line the holes up, the 3 holes with the 3 pins, then go ahead and slide it down until it won't slide any further downward. And we'll do that for both. So make sure to plug those servo cables on all the way down. It should sink down about 1/4 to 3/8 of an inch to get all the way down. And you'll know because if you look at it edgewise here, you won't really see any, like if it's not properly plugged in, trying to loosen it. Like what you don't want to see is some leftover metal on this. You don't want to see any of this lead right here. You want to press it all the way down so that the lead is all covered up by the plug. Okay, and then we will grab the wheels and just push them down over these servo splines here and here. That way we'll be able to see the wheels turn as we run our tests. Don't worry about putting the O-rings on just yet. We'll have you do that later. So these wheels, they have a side that will fit right on top of the servo spline. Got a thumbs up already. Good job. 1, okay, 2, 3, 4, 5, 6, 7, 8. Excellent work. 9, 10, 11, 12, 13, 14, 15. I really appreciate the thumbs up, you guys, because that helps me pace this properly. Okay, yeah, yeah, if you have an older Cyberbot robot, your servos might not have part numbers. Okay. Well, let's see about, so this is where we want to start with this Cyberbot template. Okay. So that's got this this bot of 21.write digital 0 and 1 to blink the light. And what we're going to do is we're going to modify this so that it sends the stay still signal to the servo. Oops. All right. So again, your power is already set by default to 5 volts, and that's good for the 08 servos. So everybody should have this set up currently. You can turn power on. That's perfectly safe to do. So, but you want to set it all the way to 2 this time. And then this is for later. Note counterclockwise and clockwise when looking down at the wheel. And here's our script. So we'll go ahead and enter this script. I'll go ahead and enter it and then just paste it to you. What's the script say? P18. Okay, so we're going to make the P18 wheel turn probably, even though we're telling it to stay still. So bot of 18.servo underscore speed of 0. All right, so that should be our entire script. And we can say test P18 servo, confirm the name, and we'll save it later after we're sure it works. Okay, so I'll paste this to you. And what do we do with the rubber ring? Just save it for when you build the Cyberbot. You'll want to put it on the wheel before you put the whole Cyberbot together, but for now we don't need it. Okay, so there is the script. And again, you'll want to paste this over your template file, the one that blinked the light. And once you've got that and you flash it, what you'll notice is that the P18 servo will probably start turning slowly. Now, again, for the one person who has the servo part number ending in 40, yours should not turn. Yours should stay still. But we will be testing speed and direction control in just a little bit. So so hang in there, and make sure you've got your servo connected and that it stays still. All right, so next up, what you'll want to do is there's a small hole You know what? I think I have videos or a good picture of this coming up. Oh, darn. Okay. Yeah, I didn't get that part added to the slideshow in time. All right. So that being the case, there is a small hole right by where the cable comes out. And you might even be able to see there's a little cross in there for adjusting with a Phillips screwdriver. So what you're going to do is you're going to put the Phillips screwdriver into that small hole. Don't press very hard at all. Be very gentle. And what you want to do is go back and forth with the screwdriver, and you'll see the speed and direction go back and forth. And what we're searching for is called the stop band, the area where the wheel doesn't turn at all. And it should be in between the clockwise and counterclockwise. Now you can see my wheel's turning very slowly. So I'm going to have to go in and readjust it and kind of try to home in on that 0 speed setting again. And so we want to make sure that that servo that was turning stays still. Thumbs ups are already coming through. You guys are awesome. All right, well, I'm going to modify the script to make both the wheels stay still. So I'll just add bot of 19 servo speed of 0. Go ahead and give you guys this modified script. And when we try this, our other servo should start turning. And we'll want to go through that centering process again to make sure that using the screwdriver, again, going into that little hole above the cable right there, and very gently turn the screwdriver, and it'll speed up and slow down, change direction. And in between the direction changes, there's that little spot where it should stay still. So now both my servos are centered. How are you guys doing? Another thumbs up. Okay, good job. Excellent, excellent. Okay, the thumbs up are coming through. I think I'm up to 7, 8. Thank you. So while I'm waiting for a few more thumbs up to come through, what I'm going to do is modify this script. I'm going to go, we'll go 65 in the counterclockwise direction and then negative 65 for the clockwise direction. So after you've got your servos centered, I'll add a comment here. How can I find the hole to center my servos? They are already on my robot. Ah, okay. So if they're already on your robot, they'll be hard to get to. So my tip there would be, okay, so here is a assembled robot. And what you'll want to do, oh, just a second. I want to get one that has servos that need to be centered. Yeah, here we go. All right, so the way to get at these servos to center them is to take out the battery pack. So you'll pull out the batteries, and then you'll unscrew these two screws. You'll unscrew these the little screws. There's two little white nylon screws that are holding the battery pack in. Once you take the battery pack out, then you'll be able to get the screwdriver in right there where the hole is. And you'll take the battery pack out, you'll put the batteries back in, and then you'll have it running and the wheels will be turning. And then you can go in and adjust it. It's don't try to do it with the battery pack in like this, but once the battery pack comes out, you'll be at an okay angle to get in there and adjust it. Okay, so let's see here. We have one that says your servos won't turn. Is your power switch in position 2?
Yes.
Okay. Let's try a program to make the servos go. They might have been centered already, possibly. I don't know. Let's try this script because this, oh, let's see. I'll make these go for 5 seconds. Okay, so these are going to turn your servos in opposite directions for 5 seconds. Paste. There we go. Okay, so now I'm ready to run this. One, two, three, four, five, stop. Okay, good. So that test passed. Carefully observe because we're using negative 65 for clockwise and positive 65 for counterclockwise. So you should see the servos turning in opposite directions. And you can go up to about 115 and you can go down to about 30 in absolute value. So like if I wanted to half the speed, maybe 30 and negative 30 would go nice and slowly. Mine still don't turn. The amber light flashes, but no spinning wheels. Okay, so did you flash the, so did you paste in and flash the script?
Yes. We blame the Lenovo computer again.
I get, oh, well, that would be why. I think that, I mean, did you succeed in getting the Cyberbot module added to your,
I did. Everything's worked up until now. I managed to get it working and then it just, the wheels just don't spin. Everything else has worked.
is the amber light still flashing though?
Yeah.
All right, we'll continue with this after the
Okay.
session. In
Okay, thanks.
in just over 12 minutes. You're welcome.
Okay.
Sorry
Mine
we're having,
won't turn either.
really? Okay,
Yeah,
now.
I even put the code in the script you just put in, and
Uh-huh.
it won't spin either.
All right, so another thing you want to do is you want to check to make sure you've got the white, red, black, and the servos fully plugged on. So that's going to be here. So you want to have P18 and P19, white, red, black. You might try pulling each servo plug up, making sure that the 3 holes are aligned and plugging it back down. You got to make sure that that battery pack is plugged all the way in. You want to make sure that the blinking amber light worked out. See, check that you plugged into P18 and P19, and I got it working from somebody. Okay. So for those of you too that I'd like to meet with you after to make sure you're up and running. So we've got 11 minutes left. I want to make sure that everybody who has it working gets a chance to try a couple things. You can try, like I said, -30 and 30 will go slowly. And you can also try full speed. That would be 115 and -115. Again, we're keeping the servos going opposite directions. Now they're really trucking. And of course, you can also change the amount of time to like 3 seconds if you want. Then your wheels would roll a shorter distance. And so go ahead and play around with that for a little bit. Try values again between, say, I think you can even get away with like 25 to go real slow, but be sure that they're still gonna both turn. See, can I do one fast and one slow to make the robot spin? You absolutely can. Or you can make it spin in place by making them identical values. Basically, after you put your robot together, this is having them both turn the same direction would cause your robot to spin in place. And the wheels actually have to turn opposite directions to either go forward or backward. And that's why we use a negative. And then, yes, different speeds will result in like a curve. So for example, I could say maybe go pretty fast on the left wheel and then kind of medium speed on the right wheel, and I'd have a nice strong curve. Oops, I saved it. I didn't notice that much of a difference in speed there. Oops. All right, so now one wheel is turning pretty slowly and the other's turning fast, and that'll give me a kind of a curving thing when the robot. Oh, actually, I need to have them be still opposite signs, and that'll give me a good curve. 30 and 100. So that is speed control, and so talking about speed control, Actually, this is a little bit outdated because it says 125. The official top speed, to the best of my testing ability, is about 115. And then can go down to 15, but I usually start at 25 just to make sure that the wheels still turn. So this is your speed control region here between, say, 15 and 115. Sorry, I'll update the slide. Negative 15 and negative 115, and then positive 15 and positive 115. And then there's a overdrive range where basically you can ask it for 200, but it's still only going to give you 115's worth of speed. And so if you have it at 115, you can slow down. You'll also notice that it won't go perfectly straight, even though you have identical values. So you'll need to slow down a faster wheel to straighten out the path of the bot. And we'll get to play with that on Wednesday. This is a graph of the value. 25, let's see. So if we say 25, we're kind of right about here. So maybe negative 10 RPM. And then if we give it negative 50, well, that gives us negative 30 RPM. And then once we're up to 100, we're almost at 50 RPM. And then likewise on the other side, if we give it 25, well, we might get 10 RPM. And if we give it 75, well, we might get between 30 and 40 RPM. See, do we put the screw back into the wheel servo? We'll save the screws. You'll be doing that. You know what? You can temporarily just put them in. Just whatever you do, don't lose them, because you'll need to screw the wheel onto the servo after you put the robot together. So save the screws. Very important. All right. There's a little under the hood lesson. If you've ever set up a blinking light where you give it 0 volts and the light stays off, and then you give it 3 volts, say, and the light comes on. Well, if you imagine that it stays on for 1.7 thousandths of a second, that would be that overdrive maximum speed in the counterclockwise direction. 1.3 thousandths of a second on time would be and delivered every 20 thousandths of a second would make the servo turn clockwise at top speed. And then 1.5 thousandths of a second is what would make it stay still. And that's what we used, is that 1.5 thousandths of the second. When we gave it speed 0, this is the actual electrical signal that it was sending, was 1.5 thousandths of a second on at 3.3 volts. And if you connected a light to it, you could see it flicker if you were a computer. The eye can't see it. It just looks dim. And then there's 20 thousandths of a second between each of these. They're called control pulses. So again, these are all links to chapters that are in the book. I kind of walked you through it. This is identifying the servos, whether they end in 40 or 8, and then plugging them in, and then with the power switch, and then what your setup should look like. So it's all there. And then here is the script. So this is what we just went through right here. Paste. And actually this is part of a larger chapter. And like this was the connect your microbit, where we went through and connected the microbit. And then this is the Cyberbot board. And I'd like to point out that there's a low battery indicator that's in the upper right part of the board. And this is all part of the Build Your Cyberbot chapter, which you're going to be finishing with putting your Cyberbot together. So you'll be getting all these parts, and then you'll be going through step by step, and I'll be sending you these links. You'll be saving the screws, and then putting the servos into the chassis, putting the battery pack into the chassis. There's a rubber grommet where the where the cables come through. And you'll be doing all this too. And then here's where you'll be putting the O-rings on the wheels. And then this is where you will finally be using that screw to hold the wheel to the servo. So again, save the screws. You'll need them at this step. All right, sorry, I'm running just a little bit over time. Try to get you out of here as quickly as possible. I'm showing 2 minutes left, but I might go a couple minutes into the next hour. Apologies, I'll go as quickly as I can. So anyway, I'll be sending you the links to those parts of the web textbook. And I do want to point out that you can put the servos into the Cyberbot so that the drive shafts are closer to the center of the robot. It makes it so that you have to pop the battery pack out if you need to readjust the servos. So that's the downside. But the upside is that it navigates better. If you have it front mounted, it's really easy to get at those adjustment screws. But if you try to have it turn in place, sometimes the wheels slip instead of it dragging the tail wheel around in a circle. There's a mechanical disadvantage of the wheels when they're up front like this, as opposed to closer to the center. So the upside is this is easier to adjust if you need to readjust, but this performs better. Make sure to set your power switch to 0 and unplug the power. Okay, so that's power switch to 0 all the way to the left. And then I'm going to unplug the battery pack right there. And that will save your batteries because there's no way that it can drain it. What's the difference between power switch position 1 and position 2? That's an excellent question. And the answer is that if you build circuits here, position 1 will power these circuits, but they won't power the servos. So position 1 is nice for loading the script, and if you have some sensor circuits, you can actually test the sensor circuits without the servos trying to blast off, and jump off the table on you. Then once you're happy that the sensors are working, you can set the power switch in position 2, and then it'll start moving because position 2 also includes the servos. It gives power to the servos as well as the circuits. Yeah, I agree. It's a nice feature. Okay, so that I believe is see, so that's going to be Wednesday's homework. Yeah, so that's it. So basically, I will send you homework links to actually, I'm just going to paste them in real quick while we're here. And then that way you can just grab them. Okay, so it's going to be Cyberbot. Build your Cyberbot. And we've done this, so we'll be at building the chassis and all its subpages. Okay, and then attach the board to the chassis, which is a single page. So those are your 2 main links, and just keep in mind that build the chassis has a lot of subpages. So we'll have you put together the Cyberbot between now and Wednesday, and then we'll tune the forward and backward motion and start building some sensor circuits on Wednesday. Let's see. How well does the curriculum work for college students, 2 to 4 year? It's used in college. It's funny. It just depends on the goal of the class. For example, a class in Harvard is using it just as a physical way to see some of the computer science concepts in a basics of programming course, and then 8th graders will use it in also in their computer science classes. It varies greatly, and we put all the information up in the web book, and then we let the teacher decide what they want to emphasize or leave out, depending on what their class can do. So thanks for coming, everybody. I'll email you those links, and then we'll see you Wednesday with constructed Cyberbot robots that we will start navigating and then build sensor circuits on. And for anybody who needs tech support or has questions or comments, please hang out after the recording ends and we'll get you covered. Thanks for coming.